Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Actually, if I look at the clock, it's 5, so it's good afternoon. All right, today I will be going through test number 3 review. Let me remind you, this Thursday, 8 a.m. or earlier, I will send out an email with the password for the password protected PDF file for test number 3. You'll have until Friday, 8 p.m. Take the test. Spend as much time as you want, but do not go on the internet. Do not ask for help. That's cheating. Please don't. And then make sure you upload the test number 3 as a single PDF file to D2L. And I've already posted, let's see if I can get to that real quick. And test number 3, as I have in the announcement that I put out on the 28th of October, that's a while ago. Test 3 has 9 pages, 10 problems. It will cover, again, all my tests are multiple part, never multiple choice in this class. It will cover carboxylic acids, esters, carboxylate anions, amines, amine salts, quaternary ammonium salts, which are near and dear to my heart, amides or amides, depending on which side of the ocean you are. English pronounce it actually amides, but here in the United States, amides, and heterocyclic compounds. And the point breakdown is 7 points general knowledge, 38 points nomenclature, and 60 points reactions. And there's 5 bonus points. So let's get going. And I will be posting this in my YouTube channel. All right, let's get started. First of all, this is the structure of a carboxylic acid. A carbonyl, carbon double bond oxygen, with an OH on the carbonyl carbon, also known as the hydroxyl group, and an R group carbons and hydrogens. How do you name it? The IUPAC nomenclature rules are: name the longest chain that contains the carbonyl carbon and the R group carbons. Name it as an alkane. Drop the E, add OIC, and the word acid. Oh, excuse me, I'm getting all choked up over this stuff. Remember, the carbonyl carbon is always number 1, and you don't need to put that down. All right, I asked you to learn some common names. First of all, when R is a methyl group, that's acetic acid. Nobody calls it ethanoic acid, it's acetic acid. And about 4% of that and 96% water, acetic acid and water, is a product we call vinegar. Next, when R is a hydrogen, that's formic acid. And that in water heated up is the defensive weapon of the fire ant. And finally, when R is a benzene ring, both the IUPAC and the common name is benzoic acid. Let's talk about reactions of carboxylic acids. An acid is a proton donor, and the proton that gets donated, the acidic proton, is this one right here. So if I react it with a base, MOH, where M can be lithium, sodium, or potassium, acid base, you get this carboxylate anion. Now, you don't have to put the charges down, but I do. I think it looks cool. And you get water, but I ask on a test, give the organic product or products, and water is not organic. Now, there's one special reaction, which I talked about in the video, is a carboxylic acid plus baking powder, otherwise known as sodium bicarbonate. And when you react that, you have an acid and base reaction. And this is one of the few reactions this whole semester I asked no all the products. And you get the carboxylate anion, the sodium salt, but the baking powder, sodium bicarbonate, forms carbonic acid, which like that or quicker, actually quicker, breaks down to water and carbon dioxide as a gas. And if you saw the video, which I hope you did, my father taught me this reaction when I was 5. We put it in the little rocket ship tube and built up pressure and went off. Oh, that was great. Next, how do you make a carboxylic acid? If you take a primary alcohol and oxidize it, O in brackets means oxidizing agent. I'm not asking you to memorize all of them. I'll use the general form like that. You form a carboxylic acid. One thing I should remind you for test number 3, how many bonds to carbon? 4. I could get that finger fixed. 4 bonds to carbon. Do you break carbon-carbon single bonds? No. I'll say that again. 4 bonds to carbon is your friend, and do you break carbon-carbon single bonds? No. So here, you start out with a primary alcohol, and you end up with a carboxylic acid. The carbon with the hydroxyl group becomes the carbonyl carbon in the carboxylic acid. If you take an aldehyde and oxidize it, which I did for my PhD thesis, some of the reactions like this, you now replace the H with an OH, and you form also a carboxylic acid. Now, a really cool reaction is when you take a Grignard reagent and react it with carbon dioxide. Sometimes it's done with dry ice. That's why it's so cool. Bad joke. Anyways, second step, acid and water. You get a carboxylic acid that's 1 carbon longer than the R group. Here, X can be chlorine, bromine, or iodine. And those are the reactions to make carboxylic acids. Now, a derivative of a carboxylic acid, something that's made from it, is an ester. An ester has a carbonyl group with an R group, and then to the carbonyl group you have an oxygen, then R prime. Remember, R means anything with carbon and hydrogen in it. What is thirsty word? And how do you name that? Well, there's 2 ways. One, the IUPAC, name the R prime as the alkyl group in front. Now, the second step, 2A, name the carboxylic acid used to make that ester, pretend R prime is a hydrogen, drop the OIC and the word acid, or actually drop the IC in the word acid, sorry about that, and add ATE. Now, as a gift, I will not have any substituents on the R group here, but you do it like you normally would, but that makes things hard. Now, a student of mine a number of years ago came up with another one for all carboxylic acids essentially, except when R is benzene. And that's name the longest chain, including the carbonyl carbon. Well, first of all, you still do step one. R prime is an alkyl group in the front. And then instead of 2A, you do 2B, or not 2B. That's quite, I can't stop from doing that. You do B2. Name the alkane from the longest chain with the carbonyl carbon in the R group, and drop the E and add OATE. And to explain how to do it the second way using B2, this is an ester. R prime is a methyl group. The longest chain with the carbonyl carbon is this. That's propane. Drop the E, add OATE, and that's methylpropanoate. Aren't you glad I'm not doing enunciation quizzes? So am I. And that's how you do an ester. Now, there's only one common ester I'm asking you to learn, and that's this. When R is an ethyl, R prime is an ethyl, and this is a carbonyl plus a methyl. And nobody calls this ethyl ethanoate, it's ethyl acetate. And ethyl acetate is one of the two chemicals used for nail polish remover. There's other uses, but for you, every day you were go to a big box store and look at nail polish remover, there's two types of molecules. Acetone, which I taught you a ketone before, and ethyl acetate, this ester. Now, I showed earlier, but now let's talk about nomenclature, the carboxylate anion. And here you have a carbonyl R group, O minus to the carbonyl, and this O minus, an anion, has a cation M plus, where M can be lithium, sodium, or potassium. And how do you name this? You name M plus as the element it comes from. If M plus was lithium, you'd put lithium or sodium or potassium. And then part two, you can either use A or B, just like the ester. Now, when it comes to esters, they're responsible for the smell of most flowers and the taste and smell for many fruits and vegetables. Next time you smell a banana or taste it, you're tasting an ester. Now, how do we make an ester? You do that by this reaction. It's called Fischer esterification, named after the great German chemist Emil Fischer, Dr. Emil Fischer. And we'll learn more about other things he did when we get into carbohydrates and sugars. Now, to make an ester, you take a carboxylic acid, react it with an alcohol with acid catalyst, that's the H plus. And you lose water, and the oxygen from the OR prime is bonded to the carbonyl. The oxygen is still bonded to the carbon in the R group that was in the alcohol. Well, now that you have an ester, what can you do with it? The first one is acid hydrolysis of an ester. Acid, H plus, and water, and you react it with an ester, and you get back the carboxylic acid plus the alcohol you would have used to make that ester. And this is an important reaction. Later on, you'll find out that's how your stomach And intestine breaks down fats and oils to make fatty acids and alcohol or glycerin that your body uses. So again, ester, acid, and water, you get a carboxylic acid and the alcohol you would have used to make that ester. Now, you can also do base hydrolysis. This is called, and I'll never ask on a test, but I still should tell you, saponification of an ester. And what you do is you react an ester with base, MOH, and water. Hopefully, you all know that's H2O. And M can be either lithium, sodium, potassium in my class. And there you get not the carboxylic acid like you get up here, but you get the carboxylate anion of the carboxylic acid you would have used to do that. Why? Because when you form this carboxylic acid, it immediately reacts with base to form the carboxylate anion. And if you put the carboxylic acid here with base, I'll mark it wrong. You also get the alcohol you would have used to make that ester. And that's called saponification, because we'll learn later on that certain carboxylate anions are soaps. Now, one of my favorite reactions, because you use a Grignard, I don't have here and I better write it down. And that's if you take an ester, react it in the first step with 2 molecules of a Grignard, and second step, acid and water, you make not just one, but 2 carbon-carbon single bonds, something very special, very rare. And this OR prime gets kicked out as an alcohol. So let's do one of these. Let's have some fun. Now you know I'm an organic chemist, if you haven't figured that out by now. Oops, should have made this arrow longer. And the question is, what are the 2 products you get? And on a test, if you see a plus sign that tells you 2 products, that's my gift to you. So what do we have here? You should be able to identify functional groups, look for what's different, what's not oxygen, what's not carbon, what's not hydrogen, should get your attention like that. And here we have a carbonyl, oxygen with an R prime, and R, ester. And what's different here? Magnesium chloride and a carbon. And I should have put here 2 of them. I forgot to do that, but I didn't on the test. Oops. And here we have a Grignard second step acid and water. Remember, X can be, as in our case, chlorine, bromine, or iodine. And what you get are 2 alcohols. The first one, you make not 1, but 2 carbon-carbon single bonds. And the second alcohol comes from here. So this is R. This is R prime. And here's my R triple prime. So my R group is methyl. Keep your eye on the carbonyl carbon. That's where the fun is, which is this carbon right there. then the carbon with the the Grignard, this one right here, will be bonded to the carbon that was the carbonyl carbon. Sorry, running out of space. And remember, you don't break carbon-carbon single bonds, and there's 4 bonds to carbon. And then we also get this alcohol from this R prime group, which in this case is ethanol. And that's how you do it. Oh, that was fun. Now, the next area I talked about was amines and amine derivatives. And a derivative means something that's derived or made from an amine. And if you watch the videos, which I hope you all did, for a number of years, I worked in this industry, and I have a number of US patents, so it's very near and dear to my heart. All right, amines are where you take ammonia, NH3, and replace the hydrogens with R groups. Primary amine, which I'll not ask on a test, secondary, tertiary amine. How do you name that? Well, I didn't give you the IUPAC because nobody really uses it. Most people, if you work in this industry, use the common names. Name each R group as the alkyl group it is in the front, and then add the word amine. Now, there's one special amine I asked you to learn. When you have a nitrogen with 2 hydrogens and a benzene ring, that's called aniline. That's both the common and the IUPAC name. And aniline is used in our chemical industry to make many, many important things, which I'll talk about later in the semester. Now, something really near and dear to my heart is a quaternary ammonium salt. Unlike carbon, nitrogen can have 3 bonds to it and 4 bonds to it. And here in a quaternary ammonium salt, we have 1, 2, 3, 4 R groups. Because there's a plus sign, a charge on nitrogen, all molecules have a net 0 charge, so you need an anion. For this class, I'll just stick to halogens, X minus, where X is chlorine, bromine, or iodine. Now, again, I'll just ask you to know the common name. Name each R group as the alk group in front, and then add the word ammonium halide. And the halide, when X is minus is bromine, is bromide, Cl chlorine, chloride, iodine, iodide. Now, there's something else. Oh no, I've got this wrong here. Well, I told you the first day, I don't walk on water unless it's frozen. Even then I stay off. But anyways, this is an amine salt. Unlike a quaternary ammonium salt, an amine salt can have 1, 2, or 3 R groups on it. And it has the remainder are hydrogens, total of 4, but it doesn't have 4 alkyl groups. That's a quaternary ammonium salt. And you name it the same way as a quaternary ammonium salt. Name the R groups in front. Then put the word ammonium halide, just like up here, where bromine, bromide, chlorine, 1X chlorine, chloride, iodine. Now, how do you make amines? Well, if you take an alkyl halide, Rx, and react with ammonia in the presence of base, and I won't tell you the different bases you can use, I'll just put the word base, you get a primary amine. Remember, the nitrogen from here bonds to the carbon that has the halogen. The nitrogen ammonia bonds to the carbon which has the halogen. And you lose a hydrogen, and here's a primary amine. 3 bonds to nitrogen. Now, if you take a secondary amine, or primary amine, I'm getting a helpful, and react it with our prime X, again, this nitrogen will bond to the carbon in R prime with the halogen, and you'll make a secondary amine. This was a primary amine. And if you take a secondary amine and react it with an alkyl halide and base, again, this nitrogen attacks and bonds to the carbon in R double prime with the halogen and kicks out the halogen, and you get a tertiary amine. Now, something again near and dear to my heart, because when I joined the chemical industry, this was the first reaction I did research on. And that is if you take a nitrile, and this is a triple bond with 2 pi bonds and 1 sigma bond, just like a carbon-carbon triple bond. And you add hydrogen and excess hydrogen, because you have more than 1 pi bond, you're hydrogenating, and a catalyst, nickel, platinum, or palladium, you break the 2 pi bonds, and each atom of the triple bond, carbon and nitrogen, get 2 hydrogens. And this is a great way to make a primary amine. You can write it this way or this way. Now, something really near and dear to my heart is making a quaternary ammonium salt. And I forgot how many US patents I have using this reaction, a number of them. And here, you take a tertiary amine, react it with an alkyl halide in the presence of base, and you get a quaternary ammonium salt. And I worked for a company that made about 100 million pounds a year of quaternary ammonium salts, different kinds. And so this is really near and dear to my heart. Remember, a quaternary ammonium salt can be used as a fabric softener, which I have patents in, and I worked in that industry, or as an antimicrobial compound, something that kills microbials or bacteria. And I told you the story about the mouthwash that I now use that has a quaternary ammonium salt and keeps my gums nice and clean and healthy. All right, now, amines are bases. And if you react it with an acid, you get an acid-base reaction. Remember from general chemistry, acid plus base, get a proton transfer. In this case, this is your base. And if I react it with a hydrohalogen acid here, this is my acid, where X can be chlorine, bromine, iodine, and you can have both a primary, secondary, or tertiary amine, which means R prime, R double prime, one or both can be carbons, or one or both can be hydrogens. And you form an amine salt. All right, let's move on. A derivative of an amine is an amide. And an amide is a carbonyl, carbon double bond to oxygen, with an R group on the carbonyl. To the carbonyl carbon is the nitrogen. And the nitrogen, you have R prime and R double prime. Again, this is where nitrogen has 3 bonds to it. But in amides, R prime and R double prime can be hydrogen. One or both or none. They could both be carbons, lots of them. How do you make an amide? You take a carboxylic acid and react it with either ammonia or R prime and R double prime are hydrogen, or a primary or secondary amine. And I worked in this industry too. And you form an amide. Remember, R prime and R double prime, one or both or none, can be hydrogen. And remember, nylon is an amide. My hair is amides. I'll teach you this later on. And your skin is a huge amide. Now, what do you do with an amide? Well, the first one is if you take an amide and react it with acid and water. The acid here is hydrochloric acid. And the reason I picked this one for this reaction, because that's the acid in your stomach. And we'll learn later on, proteins, which are amino acids hooked together in amides, they're also called peptide bonds, are broken down by the acid and water in your stomach. So if you take an amide, react it with acid and water, you get back the carboxylic acid you would have used to make that amide, like in this reaction. But because you're in acid, and the amine here that you would get will react with the acid to form this amine salt. Remember, in the amide, R prime and R double prime, one or both, can be hydrogen. And it's time for me to remind you how many bonds to carbon? 4. How many bonds to nitrogen? Sometimes 3, sometimes 4. Do you break carbon-carbon single bonds? No. Carbon-nitrogen bonds you can, but not carbon-carbon bonds. Now, you also have base hydrolysis. And if you take a base, and for this class, I use NaOH, sodium hydroxide. I have my amide. I have my base. And I have water. And you have base hydrolysis of an amide. Now, you don't get back the carboxylic acid you would have used to make that, because the presence of base, you lose the proton from the carboxylic acid and you get the carboxylate anion. From this part of the amide, you get the amine you would have used to make that amide. And the reason why amine doesn't react with NaOH base, because an amine is a base. Now, the next thing I talked about were the type of compounds called heterocyclic compounds. And you should know something? It's time for Dr. White to be subtle. You should know what is the definition of a heterocyclic compound. And that is a ring with carbon atoms and other atoms, such as oxygen or nitrogen. Now, there's only one heterocyclic compound I asked you to learn, and that's pyridine, which is both the common and IUPAC name. And that's where you have a 6-membered ring, and one of the members' atoms is a nitrogen. and it has 3 double bonds alternating single, double, single, double, single, double, conjugated. Now it looks like benzene, but where you replace one of the carbons with a nitrogen. By the way, pyridine stinks. A lot of them mean stink, or nitrogen compounds. Not as bad as thiols, but they stink. I worked with them, I know. And with that, I'm done with the review, except for one thing. Do we have time? Yeah, we got time. Let's play that fun game. Circle and name the functional group, 2 points each. And why don't you take a look at these two? And I'll give you a chance for you to have fun and circle the functional group or groups, 2 point each. Your turn. Give me a thumbs up when you're done, class. Again, circle and name the functional groups. I'll give you another 10 seconds. Time's up. My turn. Look for what's different, what's not carbon, what's not hydrogen. Should get your attention like that. And what do we have here? Oh, look. Carbonyl with an R group oxygen, R prime. You don't have to show this, but I will. And this is an ester. Now, if we look in B, ooh, nitrogen, that's different. Carbons here and here. Again, you don't have to write the structure I have here, where R prime and R double prime, one or both can be hydrogen. In our case, one is. And this is an amine. Are we done? No. Here's an oxygen, carbonyl, with a nitrogen, with R prime and our double prime on there. And here we have an R group. And what's that? Remember, R prime and R double prime, one or both can be hydrogen. In this case, they aren't. Both are methyl. And this is an amide. And that's how you play circle and name the functional group, 2 points each. I hope you had fun doing that. Now, I'm done with the review, but let me remind you about something. I sent out an email and posted an announcement of an amnesty lab program. Election night, because tomorrow night is election in the United States. And I hope you all vote tomorrow if you haven't. I voted by mail-in ballot about a week or so ago, so I've already voted. But because of that, I have done a lab amnesty program. I have opened up all the labs up to this week, and for labs that you haven't done that were already due, you have until November 15th to upload your labs so you can get points for that if you didn't. And that's my lab amnesty program. So if you haven't handed in a lab that was already due, this is your chance to hand it in and get points. The other thing I put out in the email, I have through last week, labs that were due, I think October 31st, Halloween. I hope you had a happy Halloween. I did. I had about 70 trick-or-treaters or a little more come to my house. Then my neighbors across the street had a nice party too later on. Nice. But anyways, check and make sure all the labs you handed in, except the one due this week, that's graded. If not, send me an email which lab I didn't grade, and I'll go back and grade it. Sometimes if you handed it in late, I didn't go back and check well, so do that. And with that, I'm done. Don't forget, Thursday will be test number 3. And with that, I'll stick around if anybody has any questions. But if not, I'll say, Gehen gesund, which you know that means go in health in Yiddish. My grandmother used to always say that to us when we'd leave after visiting her. Great woman. And I'll say, bye now. Stole that from Beverly Hill, Granny and the Beverly Hillbillies. Bye.